So dear students, in the last lecture we have seen how to find inverse Laplace transform by using convolution theorem, and how to use the result of division by s to find inverse Laplace transform of the given function. Okay, the convolution theorem is the one of the most important theorem for your Laplace transform. Okay, so you must remember all these things. So now students, we will start the next module, that is the Fourier series. What is the use of Fourier series in real life? See here, the Fourier series has many applications in electrical engineering, vibration analysis, optics signal processing, and image processing, quantum physics, cell theory, and it has also applications in heat distribution mapping, wave simplifications, and so many applications are there in engineering field. That's why we are going to study the Fourier series. Okay, so these are the real life application of Fourier series. Okay, a series of the form, a series of the form, a series of the form a naught plus a1 cos x plus b1 sin x and plus a2 cos 2x plus b2 sin 2x and plus so on up to what, plus an cos nx plus bn sin nx and plus so on. This series run up to infinitely many terms, and in simple way this can be written as what, constant term a naught and plus summation running from n equal to 1 to infinity a n cos nx plus bn sin nx. Okay, where 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 ais and bis are known as what, constants, are constants constants, and this series is called as what, this series is called trigonometric series, is called trigonometric series. Why this so? Because the series contain what, trigonometric function, so that's why this series is known as what, trigonometric series. So when this series is known to be what, Fourier series, so it has some certain condition, with some certain condition, if this series satisfy, then this series is known as what, Fourier series. And what are that certain condition? So the function f of x, represented by this series, so the function f of x represented by yes, the function f of x represented by, please mute your mic those who are talking in between, represented by this series is a periodic function, is a periodic function of periodic function of period 2 pi. Okay, why this so? Because if we change this function from x to 2 pi, then we will get again the same series. So because on changing x to 2 pi plus x, then we get the same series. We again get the same series. Get the same series. Okay. So what about the Fourier series? What about the Fourier series? Can you tell me what about the Fourier series? So before defining Fourier series, we must define the Dirichlet condition. Then we will go for the Fourier series. So first we define Dirichlet condition. What is the Dirichlet condition? Dirichlet's conditions. Dirichlet conditions. Okay. A function f of x is defined in the interval. Interval is given to you. A function f of x is defined in the interval your interval is what? C1 is less than equal to x is less than equal to what? C2 can be represented as or you can say express as represented as Fourier series Fourier series if in the given interval, you can say in the given interval there are some conditions. Number one, given interval f of x and its integral are finite, and its integrals are finite. This is first condition. Finite, and also it is what? Single valued. This is the one of the most important case, and single value. Okay. And number two, the second condition was f of x has finitely many discontinuities. Has finitely many discontinuity. F of x has finitely many discontinuities. Means what? The discontinuity of the function must be countable. Okay. And number three, the third condition is what? F of x has finite number of maximum and minimum. F of x has finite number of maximum, or you can say maxima or minima. Okay. Finite number of maxima and minima. Okay. So what is the Dirichlet condition? A function f of x is defined in the given interval, then this function can be represented as a Fourier series if it satisfies the three conditions. First condition is what? The function f and its integral are finite, and it must be single valued. Okay. And the second one is what? The function has finitely many discontinuities. natives. Okay, matlab the function has finitely many discontinuity means what? The discontinuity of the function must be countable. You can count the discontinuity of a point of the function. Okay, and third condition is function has finite number of maximum and minimum. Okay, these conditions are known as what? Dirichlet conditions. Okay, these conditions are known as these conditions are known as Dirichlet condition. Dirichlet's conditions. Okay, these conditions are known as Dirichlet condition. Now we will define the Fourier series. Definition of Fourier series. Okay, now we are able to define Fourier series. ये तो मटेरियल डेवलप कर रहा था मैं Fourier series को डिफाइन करने के लिए. So let us move to the next page, then we define. Definition. Definition of Fourier series. Any periodic function f of x. Any periodic function. Periodic function. Any periodic function f of x of period 2 pi. Period 2 pi which satisfies which satisfies certain condition, satisfies certain conditions known as what? Dirichlet condition. Conditions known as Dirichlet condition. Dirichlet conditions can be expressed in the form of Fourier series. Dirichlet conditions can be expressed in the form of can be expressed in the form of a naught plus summation running from n equal to 1 to infinity a n cos nx plus b n sin nx. Okay, in the form of this series and it is valid for all value of x and it is valid for all values of x, all values of x in any interval, in any given interval okay, from c to c plus 2 pi. Okay, c to c plus 2 pi of length is 2 pi. Okay, and the expansion of the function f of x in the form of this series is known as what? Fourier series. Okay, the expansion of f of x in the form of form of above series, in the form of above series is called Fourier series. Fourier series. Okay, so this is the definition of the Fourier series. So what are the definition, or what is the definition of the Fourier series? Any periodic function f of x is said to be Fourier series if it satisfies the certain condition. The condition is known as what? Dirichlet condition. Can be expressed in the form of this series, and it is valid for all value of x in the given interval. Your interval is running from c to c plus 2 pi of length 2 pi. Then the expansion of the function f of x is known to be Fourier series. Okay, this is the simple definition of Fourier series. So इस खाली definition के लिए मैंने क्या किया, इतना सारा background मैंने create किया. In the definition, we will have period of the function 2 pi. So we must know what is the periodic function and what is the period of the function. Okay, and in the definition, we also have certain condition, and the condition is known as what? Dirichlet condition. So before defining the Fourier series, we must know what is the Dirichlet condition. Okay, and using the Dirichlet condition, we are able to define the Fourier series. Okay, this is the definition of Fourier series. I hope you understood this. Okay, and examples which function can be expressed as in Fourier series and which function cannot be expressed in Fourier series. Okay, example number one. Number one is what? Which function can be expressed as in a Fourier series? Cos, we taking cos ax. Okay, cos ax can be expressed as what? Fourier series. Why this so? Because it satisfies all the conditions of Fourier series. Means what? It satisfies all the conditions of Fourier series. The condition is known as what? Dirichlet condition. So first condition is what? F of x satisfy f of x and its integral value are finite, and it is what? Single valued function. Okay, and f of x has finitely many discontinuities, and f of x has finite number of maximum and minimum point. So it can be expressed as f Fourier series can be expressed as of Fourier series. Fourier series. Why this so? Because it satisfies all the conditions. Since it satisfies all the conditions of Fourier series. Fourier series. Number two. If I take sine inverse function, sine inverse of x. Okay, sine inverse of x cannot be expressed as of Fourier series. Fourier series. Why? Because it is not a single valued function. Not a single valued functions. Okay, single valued means what? Sine inverse of x क्या होना चाहिए? सिंगल वैल्यू देना चाहिए. ऐसा नहीं मल्टीपल वैल्यू देगा तो इट विल नॉट बी अ सिंगल वैल्यू. ओके, नंबर 3, tan x is this function can be expressed in terms of Fourier series. Yes or no?
No, sir.
No. Why is this so? Because
Sir,
tan
because
function is not defined. Tan function, tan को क्या लिख सकते हैं आप? Sin x upon cos x. Okay, cannot be expressed as in terms of Fourier series. We know the result of this. Results. Some results we must have to remember. Result. Okay. For any integer, any integer n, any integer n, we have first condition. First, sin n pi is what? 0. Okay, sin n pi is 0. Number 2, cos n pi is equal to what? Minus 1 raised to n. And number 3, cos 2 n pi is always equal to 1. और बाकी बहुत सारे रिजल्ट हैं, तो आप उसको इसी से डिराइव कर सकते हो. ठीक है. सो these are the result we must have to remember. Cos multiple sin multiple of pi is always 0, and sin multiple of pi is alternate. If n is even, if n is even, so this is 1. If n is odd, this is minus 1, like this. इवन आएगा मतलब 2 4 6 के लिए कितना आएगा? 1 आएगा. और 1 3 5 के लिए क्या आएगा? ओड आएगा, मतलब माइनस 1 आएगा. ठीक है. और cos 2 एन पाई हमेशा कितना होता है? 1 होता है. आपको ये रिजल्ट आपको याद रखना है. देन नेक्स्ट रिजल्ट इज व्हाट? रिजल्ट. योर नेक्स्ट रिजल्ट वी नो वेरी वेल. रिजल्ट नंबर 1, इंटीग्रेशन ऑफ e रेस टू ax sin bx and dx, and this is equal to what? This is equal to e raised to ax divided by a square plus b square, and in bracket a sin bx minus b cos bx. Okay, you must remember this formula. And formula number 2, e raised to ax cos bx and dx equal to what? E raised to ax and divided by a square plus b square, and here we'll have a cos bx and plus b sin bx. Okay, these two result we must have to remember this. Okay, Euler's formula. Euler's formula. Okay, so Euler's formula can be used to find out the Fourier coefficient. Okay, Euler's formula, it is used to determine the Fourier coefficients. The Fourier coefficients. Fourier coefficients. Okay. And what are the Fourier coefficients? Let, if I define, इसको मैं ब्रैकेट में डाल देता हूँ. ठीक है. Let f of x be a periodic function, be a periodic function or period 2 pi. If f of x is periodic function of period 2 pi, which can be expressed as which can be expressed as, or you can say represented as, in the form of Fourier series in given interval, represented in the interval interval is given to you c2 c plus 2 pi by f of ex is equal to a naught plus sum running from n equal to 1 to infinity a n cos n x n plus sum running from n equal to 1 to infinity bn sin nx. Okay, name this equation number star. Name this equation number star, where we assume that we we assume that this series is what, uniformly convergent and integrated by term, where we assume that this series this series is uniformly convergent. Okay, and can be and integrated term by term, can be integrated term by term. Okay, in the interval this, in the interval c2 c plus 2 pi. Okay, we have the following Fourier coefficients. We have the following Fourier coefficient. The following Fourier coefficient. Okay, number 1, a naught equal to 1 upon 2 pi integration of limit c2 c plus 2 pi f of x dx. Name this equation number 1. Name this equation number 1. Then an is equal to, the second formula will have Fourier coefficient. So what is the an? An is 1 upon pi integration of limit running from c2 c plus 2 pi f of x cos nx dx. Name this equation number 2. Now next Fourier coefficient bn. Your bn is what? 1 upon pi integration of limit c2 c plus 2 pi f of x sin nx dx. Okay, and name this equation number 3. Name this equation number 3. Okay, So if in the exam you have given function, if I ask find the Fourier series of the function f of x in the interval is given to you, then first step is what? Your first step is what? Just you write down, let the required Fourier series be this. आपको लिखना है f of x equal to a naught plus sum running from n equal to 1 to infinity a n cos n x plus sum running from n equal to 1 to infinity b n sin n x, and name this equation number star. Okay, then our job is what? Our job is to find the Fourier coefficient of the Fourier series. So we first determine a naught by using this formula. Okay, and then we will determine an by using this formula, and then after this we will determine bn by using this formula. So after finding Fourier coefficient a naught, an and bn, we substitute the coefficient in the equation number star. Okay, and that will be what your required Fourier series of the given function. I hope student understood how to determine the Fourier coefficient by using your formula. Yes or no? Yes or no, student? Yes or no? Patak? Durgesh?
Yeah, sir.
So please
Yes,
reply
sir.
yes or no so that we can go ahead. Are you getting how to find the Fourier series by using Euler's formula?
Yes.
Yes कनौजिया? कनौजिया
Yes,
आपको
sir.
get समझ में आया? ठीक है, अभी देखो, अभी मैंने एक भी प्रॉब्लम लिया नहीं, अभी मैं जस्ट खाली बेस डेवलप कर रहा हूँ ताकि आप प्रॉब्लम को आसानी से कर सको. ठीक है, मैं डायरेक्टली प्रॉब्लम ले लेता तो फिर आपको नहीं समझ में आता वो सब कहाँ से आ रहा है, क्यों आ रहा है. अभी तक ये आपका बैकग्राउंड ही चल रहा है. मुझे इतना ही लगता है कि आज आपका प्रॉब्लम हो पाएगा. अभी बैकग्राउंड जब तक क्लियर नहीं होगा तब तक मैं प्रॉब्लम पे नहीं जा पाऊंगा. ठीक है, दिस इज योर बेस. ओके, नाउ द next case is what? Now we will have the cases. Okay, we will have cases. By using cases we will derive the another formula by using this Euler formula. Okay, see here, in the case if c equal to 0, then what happen? If here c equal to 0, first case, if c equal to 0, then your interval become 0 to 2 pi. Okay, and your formula become what? A naught. Your expression or your expression of the function is same, but here Fourier coefficient formula will change. So a naught become 1 upon 2 pi integration of limit running from here c will be 0 to your limit running from 0 to 2 pi f of x dx. Similarly, an will be what? 1 upon pi integration of limit 0 to 2 pi f of x cos nx dx. Okay, and bn is what? 1 upon pi integration running from 0 to 2 pi f of x sin nx dx. Okay, now case number 2, if c equal to pi, if c equal to minus pi, then what happen? If c equal to minus pi, so here minus pi and plus 2 pi, that become pi. So your interval become minus pi to pi. Okay, and your expression for the function is same, but here formula will be changed. Here formula will be changed. So a naught will be what? 1 upon 2 pi here integration of limit running from minus pi to pi f of x dx, and an will be what? 1 upon pi integration running from minus pi to pi f of x cos nx dx, and bn will be what? 1 upon pi integration running from minus pi to pi f of x sin nx dx. Okay, so there will be two cases if c equal to 0 and c equal to what? Minus pi. Okay, so let us write down that formula, or you can do it by your own. मंगेश,
हाँ
सर
तो
लिख दो ना.
ये आप लिख दो.
फार्मूला लिख दूं? चलिए ठीक है, लेट अस मूव टू द नेक्स्ट पेज. नाउ केस नंबर 1. Case number 1. First case, if c equal to 0. Okay, if c equal to 0, then your formula will be what? F of x equal to a naught is same, and summation running from n equal to 1 to infinity a n cos nx plus summation running from n equal to 1 to infinity bn sin nx is same. Okay, then this, okay, where a naught, your formula is what? A naught equal to 1 upon 2 pi integration of limit 0 to 2 pi f of x dx. Okay, and a n is what? 1 upon pi integration of limit 0 to 2 pi f of x cos nx and dx, and bn is what? 1 upon pi, bn is 1 upon pi integration of limit 0 to 2 pi f of x sin nx dx. Okay, this is for case 1. Case number 2, if c equal to what? Minus pi, then what happen? Your Fourier series what? F of x equal to a naught plus summation running from n equal to 1 to infinity a n cos nx plus summation running from n equal to 1 to infinity bn sin nx. Okay, and where we have the Fourier coefficient a naught equal to 1 upon 2 pi and limit running from minus pi to pi f of x dx. A n is what? 1 upon pi integration of limit minus pi to pi f of x and cos nx dx, and the last Fourier coefficient is bn equal to 1 upon pi integration of limit minus pi to pi f of x and sin nx dx. Okay, so these are two cases we must have to remember. Okay, and this interval will come in case of even and odd function. Okay, in case of even and odd function, so this formula will be important for even odd case. Okay, so I hope you remember this formula. Okay, these are the very interesting and important formula. ये सभी कॉन्सेप्ट अगर आपको समझ गया तो फिर आप आसानी से प्रॉब्लम को सॉल्व कर सकते हो. ठीक है, ये तो आपको मैंने बेस आज डेवलप किया ताकि आप प्रॉब्लम तक पहुंच सको, प्रॉब्लम को सॉल्व करने की कोशिश कर सको. ठीक है, अभी आज मैंने कुछ भी प्रॉब्लम लिया नहीं है. दिस इज ओनली फॉर बेस and important and basic concept. I hope you memorize this all the formulae. Okay, and in the next lecture we will solve examples of Fourier series. Okay,
ले लिया आपने.
अच्छा 1 मिनट 2 मिनट एक्स्ट्रा हो गया.
हाँ सर.
चलिए कोई बात नहीं. देखिए यहाँ पे इंटरेस्टिंग ऑब्जर्वेशन क्या है कि a नॉट में 1 अपॉन 2 पाई है. ठीक है, बाकी ए एन और बी एन में 1 अपॉन पाई है. बच्चे लोग बहुत मिस्टेक यहाँ पे करते हैं, यहाँ पर भी 2 पाई लिख देते हैं, फार्मूला गलत, मतलब पूरा आपका होल कैलकुलेशन गलत. यहाँ पर भी देखो 1 अपॉन 2 पाई है और बाकी में 1 अपॉन पाई है, इधर भी 1 अपॉन 2 पाई है, बाकी में 1 अपॉन पाई है. ठीक है, ये सभी चीज़ें आपको ध्यान देना है. अब ये सब बेसिक ऑब्जर्वेशन है जो कि आपको याद करने के लिए ट्रिक समझो इसको. ठीक है, फार्मूला अगर गलत मतलब पूरा कैलकुलेशन गलत, पूरा प्रोसीजर गलत और प्रॉब्लम भी गलत. ठीक है, फार्मूला अगर करेक्ट लिखा है, कैलकुलेशन अगर मिस्टेक है तो फिर वहाँ पे मैं आपका मार्क्स कंसीडर कर सकता हूँ. अगर फार्मूला गलत लिखा है और कैलकुलेशन पूरा लंबा चौड़ा किया है तो फिर उसके मार्क्स आपको नहीं मिलेंगे. योर फार्मूला मस्ट बी करेक्ट so that you can get some marks of your calculation. Getting?
Yes, sir.